Hello and welcome to the next edition of Conversations. Today I'm joined by two very accomplished individuals, joined by Roy Eggink. He is the chief engineer of Boeing 747-8, and Professor Harry Eggink of Ball State University. Roy is chief engineer on the Boeing commercial airplane 747-8 program, responsible for airplane performance information, performance flight tests, and product improvement for both 747-8 freighter and intercontinental. He has also helped build Boeing 767 and 777 airplanes. Roy is a 1981 graduate of Purdue University. In 2010, his alma mater, Purdue University, recognized him as the Outstanding Aero Engineer of the Year, the same award that was given to Neil Armstrong. Professor Harry Eggink, and he is of course a brother of Roy Eggink, is a graduate of Ball State University and Harvard University's Graduate School of Design. He has been teaching at Ball State since 1977. He is a registered architect in Indiana and a principal of Eggink, Monayar and Associates. He has been teaching the Aero Architecture Studio for the last few years in collaboration with Boeing. I might ask Roy, if we could begin with you and say if you could briefly talk about your life and career trajectory. What brought you to the stage you are at as chief engineer at Boeing?
It was a lifelong journey, I would say. It really started back where it was one of these careers or fascinations that started as early as I can possibly remember. At age 5, my sister took me on a plane ride just around Elkhart, where we flew around the house, and I remember being in that plane looking down, so fascinated that people could actually be elevated into the sky and looking around. And at that point, I was so struck by airplanes that I was, from there, building model airplanes, rockets that shot little airplanes up into the sky, flying U-controls and remote control aircraft. Even at my high school, we had a class where it was like an aviation ground school. I took that. I got accepted to Purdue University into aeronautical engineering. Great professors there, and learned all about the dynamics and the physics behind the aircraft. It was, I would say, a very thirsty kid, wanting to know all about the airplanes and to the depths of how they really work. I graduated in 1981, was fortunate to take a job right away with Boeing. And it so happened that the program I started with was the 747 program. It was certification and flight test. I was able to, within a month of being there, being on the biggest airplane ever built in the world, the 747, just the pilots and myself flying around into the sky and taking data and trying to figure out how to improve the airplane. It was very fascinating. The father of the 747 is a very distinguished fellow by the name of Joe Sutter. He retired in 1986. In 1986, I was identified after about 5 years working with Boeing into the Executive Potential Program. And through that, we had access to retirees and vice presidents and presidents where you could talk to them and learn and mentor from the people that really understood and had the experience of flight. Well, Joe Sutter and I really struck up a bond. He still works at Boeing today. He's 92 years old, and I've been working with him starting out as a mentor. He was always a hero first, then he was a mentor, now he's like a personal friend. Talk to him every day. In fact, well, not every day, I'd say once a week, but I did talk to him yesterday, as a matter of fact. Back in 1980, fuel cost was maybe 15% of the total operating cost. You have pilots, you have insurance, You have to pay for the airplane, so whether you have loans, but it was about 10%. At today's price, it's like 60% of the cost is fuel. So it went from 10 to 60%. So now the attention of details to get every little bit of efficiency out of these airplanes is vital to our customers in order for them to survive.
Yeah, it is fascinating that you are living your dream of this.
I feel very fortunate in that regard. I find that a lot of people within Boeing, like Joe Sutter, he's 92 years old,
Yeah.
still works in his office and still very feisty and ornery. I think that passion is what keeps you going. I think it is living a dream, but it's fun. It's every day, you know.
No, that reminds me. You talk about Joe Sutter. We talk about design. I mean, the thing that is common to all three of us here is design, and it is amazing to see that an aircraft, which was designed way back in the, probably starting 60s and 70s, right?
Yeah, it started in 1966, was the 747, yep.
And that it has had such a longevity and that it continues to have vitality. That to me is absolutely amazing. Could you maybe tell us a little bit about the origins of 747 and why that can be a fascinating story for everyone to understand?
The 747, what made it unique, the largest airplane at that time was a 707. Mainly inner U.S. It was about a 3,000-mile airplane carrying about 150 people. The airline that was really had vision back then was Pan Am, and their CEO was a fellow named Juan Trippe. This guy was visionary, and he wanted a very big airplane that flew from the U.S. to Europe or the U.S. to Asia. When he asked us, well, can you build us an airplane that can carry 350 people and fly 5,500 miles? Our CEO at the time, Bill Allen, says, yes, we can build that. Well, if you build that, I'll buy that. And that's what launched the 747. It was a handshake between our CEO and Juan Trippe. You build it, I'll buy it. That's what got us going. So this airplane was 3 times larger than any airplane ever flying. And it flew twice as far as anything has ever done. So it was massively big airplane, 196-foot span, 220 feet long. I mean, it's almost the length of a football field, if you think about it. The length of that airplane, it was launched, and then it came out in 1969, 60 years to the date of the first flight of the Wright Flyer.
Yeah.
The Wright Flyer flew only 50% of the length of that airplane. So its first flight didn't even fly the whole length of that airplane. That's how that technology has zoomed, through the time in 60 years.
You told me a story of how the concept of 747 took root. And we talked about the notion of designing in the shadows. Could you tell us a little bit more about that moment in the evolution and the process of development of 747?
It's always best to be the second program. The eyes of the corporation are on the main program, and then the people that want to work on something are there. So the people that want to work on the 747 are the ones that have the passion for the aircraft, and it makes teamwork a lot easier. When everybody has a common goal, the power of the team is way, way more powerful than just an individual. And that's what the Shadows is all about. At the time that the airplane was launched, Boeing was designing a supersonic aircraft. And that's where the massive leadership team was, and you had all this technology. Everybody wanted to be on that program. And the 747 was in the shadow. And so when we started to design that aircraft, they were called the Incredibles. Is what it turned out. There was nothing. There was a forest in Everett, And when we started this program in 1966, full up, 29 months later, we delivered that airplane. There wasn't even a factory.
Wow.
And it was I think it was mainly when it comes to the shadow of being second, the competition of trying to take it, it's the drive and it's the desire to really want to be successful and just prove that this airplane can be. And it automatically creates teamwork, and you help people out. You know, if someone's behind, everybody jumps on board, and away you go. And
I mean, the two elements that you talked about are essential hallmarks of leadership. You have a common goal, you have a great team, and you are working toward a purpose in a race against time with a stiff competition.
Yes, and then you always are starting with the end in mind. You know what you're going to do.
Yeah.
And the communication is really hard. I think what really made it is the leadership at the time. They were sacrificing their life as well, and everybody could see it.
The critical thing about architecture to me is that collaboration of science and art.
Yeah.
And the science part of it, you know, that was driven was the new technology. The newest technology always came from the airplane. And I remember being invited to Boeing years and years ago to look at air quality. That's when we were having problems with air quality in houses. At the same time, the airplanes were having difficulties with the air quality in the airplanes. And we had a major discussion, you know, what architects were doing and what engineers were doing. So there was a kind of a collaboration going on even back then. And then, of course, in architecture, we're in an area of sustainability, where we're looking at second lives. Everything we see should become part of our building, whether it's something that people discard. And that got me to the airplane graveyards. So I started to take a look at the graveyards, and I was wondering, all these hundreds and hundreds of airplanes just sitting there doing absolutely nothing. Yeah. Could something be done? And so I started off stumbling this idea in the studio for only 2 or 3 weeks. You know, tell a student, hey, why don't you look at an airplane and see what parts they are and what can we do with these airplanes? Because there's hundreds of all of these. And of course, at the same time, I have a great respect for the airplane, because the way, you know, Roy would always talk at home about the airplane, the technology, it really hurt me to see these things just taken to Arizona, landed in the desert, and nothing else would ever happen. Right. So somebody has to do something about it. And in talking with Roy, he also suggested the idea of a refuge. He says these airplanes are extremely, you know, extremely solid. They're very much integrated in their design. They become, you know, wonderful refuge in case of any kind of you know, climate disaster that we might have. So that became another issue. And then of course I got the studio in the graduate studio, you know, which you provided, and that gave me 15 weeks. 15 weeks to explore. I called him up right away to say, can our kids go to the Boeing plant? Because once they see the plant and they see how an airplane is put together by all the little pieces, because the only thing we could actually see was the whole piece. And so if they could take the whole airplane apart in their mind somehow, could we come up with different ideas? So we had a wonderful plant tour. We went to the Future Flight Museum there, and the director was just wonderful, showed us everything that was going on. So that year was very successful. And then, of course, we took another crack at it this year, and I think it got even better.
Yeah, what is fascinating is in the tour that all three of us were present and Roy generously provided, we saw an extraordinary organization in Boeing, and the process of design, the process of manufacturing and assembly, the whole supply chain that is spread all over the globe, and that has been taken to another level with the 787 project as well, were utterly fascinating. And as we were talking the other day, it appears that it is not just aircraft as an object, but actually the entire process and the supply chain and the organizational aspects of how that particular artifact is actually made. That is also instructive to us. Roy, if I could ask you on that front, how has that evolved, the organizational capacity and developing the knowledge and becoming now, perhaps the biggest aircraft manufacturer in the world?
Evolution is slow, it really is. If you think about it, we start with, it's actually like Ford in Detroit with the Ford Tri-Motor really started the assembly process for aircraft. When Boeing started, we adopted the same principle, and you're starting with one airplane, a 737. Mm-hmm. You build it all in-house. Yeah. Then we look at that aircraft, and engineers, the way you can tell a true engineer is you ask them to do something, then you ask them to do it again, and they'll never do it the same way twice. Mm-hmm. There's always a better way. You look at it and you go, well, we can improve this. Mm-hmm. When we did the 777, we then again expand that even further. Mm. And at that point, systems technology is coming on. Mm. So you're now able to digitize the entire aircraft. And as soon as you digitize that aircraft, everybody's working on the same print. Mm-hmm. Now everybody has the same drawing to build from. So
the master model.
It's right. And now all of a sudden it becomes even easier to We were building our own wings. Japan was building the fuselage. We would have the tail fins built in Italy. Mm-hmm. We could have the tail tips, the wing tips built in Korea. Yeah. And as the other countries are coming on, we would send digital. They would learn. They were building cars so they could naturally go into the aircraft industry. And we just evolved into a global enterprise. Mm-hmm. So when you do that, everybody's building from the same print. They go together like a Fisher-Price toy on Christmas Day. Yeah. It just snaps together and voila, there you have it. Mm-hmm. And that became the whole philosophy. Yeah. So the more you're able to assemble, which is really what the Everett plan is all about, is an assembly. Yeah. So you have parts that come in.
Harry, could you maybe talk a little bit about how architectural industry, if you will, operates and what we could learn and what you have learned from your interactions with Boeing in terms of the system, the organizational aspects of how buildings are made?
Well, coming from the Elkhart area, that's where the mobile home industry started. Yeah. And so that kind of a housing technology has always been there. And then for many years, I was a consultant for the manufacturing of homes in Indiana. Yeah. And we would I would take my students and we'd go to one of the factories of how they build. And like Roy said, it's slow going. It's very slow going. We're still building with 2x4s, of course, and we always build to the lowest economic denominator. But the technology, it's still the same process because they do build the frame system and they do insert, like the cabinetry, the windows, they come from Anderson in Minnesota. The cabinetry may come from Kentucky. So there is that engagement going on. And then at the end, they put out a product, and the product would come down and settle.
Architecture, the cutting edge part of architecture, has learned so much from the aeronautical industry. Yep. In particular, starting with Frank Gehry's experiments back in late 1980s and early 1990s with CATIA, the software, the staple software of the aircraft industry, was used, and then a lot has been learned about how aircrafts are put together that could be applied to architecture. and that has now evolved into what, Harry, you've just said, which is really digitally comprehensively modeling the artifact and simulating the performance of it. So you know the energy, structural, any other systemic performance aspects of buildings that we learn from really predominantly the aircraft industry. So there seems to be something emerging between these two industries that is utterly fascinating. However, I think the collaboration that we are talking about here seems to take it to another level. So maybe could you talk about, Harry, briefly, what maybe one specific example of maybe one project that really exemplifies this coming together of not just artifacts, but also the knowledge and the organizational capacity that we are looking at.
Yeah, I think one idea is the idea of a disaster.
Yeah.
Like, for an example, when there is an earthquake, when there's an earthquake like Haiti, it takes us over a week to get in there, move the road, and get some clearance, to get the medical devices in there, to get the search equipment in there, to find the people that are still alive. And right now it's basically done by hand tools. And so one of the notions is, can we find that capsule? And the capsule happens to be the second life of a 747, is to use part of that fuselage to create medical facilities and also the rescue component.
Could you talk a little bit about why 747?
Because it's large. It's about 20 feet in diameter, and it's just perfectly set up. Yeah. It already has the floor component, so that underneath you can have all the kind of supplies, the energy that's required, for an example, for a surgical unit to be on top. Yeah. And these units, if designed, they can be at a critical site within 4 hours.
And as you mentioned, will the capsule sustain? Yeah. And as you were discussing this, I'm thinking, well, think about the B-52. The B-52 bomber, it came out in the early 50s. It's still flying. Yeah. They still have these aircraft over 70 years later still working. Yeah. They're ready to go, they're ready to fly. The capability of an integrated design is amazing. They're lightweight. Yeah. You can lift them up, the floor, the walls, the ceiling, all of it is so integrated that it becomes its own tight capsule. I was actually quite impressed with the students and their ability to utilize either the entire fuselage or components of the wing or the tail fin or even the engine cowl itself for applications was very impressive. Yeah, I think it's there, that the opportunity is there. It's been touched out there in the industry for, as Hari explained, for a home or something really quite novel. But can we really take it to the next level and make something useful? Yeah. Really useful and affordable. Yeah. Yeah. I think is where we're headed.
What kind of value would this bring to the, let us say, the life cycle of an airplane in terms of the architectural application ideas that we have been talking about?
When you buy anything, let's say you buy a car, it's really the loan to value, residual value we call it. Yeah. If there's a second life of any product, the residual value is higher. Therefore, you can afford to buy it because you got a loan. And when you go to resell it or sell it out, it has value and it has reuse. It would be a very big impact to the industry. Typically what happens, like an older car, it just becomes obsolete. Then what can you do with it? You have to basically, it's gone for free. And now when you have such a well-integrated design and then you can utilize it for something useful, it would be really, I think it'd be a very big help to the airline industry.
Harry, what do you think is the value to the building industry in terms of what we could do with the second life of aircrafts?
I think at first, I think we can utilize these as safety areas, you know, for tornado alleys and flood conditions and so on. But I think it has the next response, because I think students will start to pick that technology up and change the way we're building.
Yeah.
You know, so that we're much more responsive, you know, to some of the climate issues that we're dealing with.
Yeah.
You know, and it's also, like you mentioned earlier, about design process.
Yeah.
A lot of times in architecture, we get stuck with the 2x4s, concrete, steel, and so on. And I think if we produce students that think way outside the box, everything they see, you know, it's got a second life. How am I going to reuse that in my field? But I think another important component is, and we've talked about this before too, is when two professions rub together.
Yes.
When you have the aero and the architects coming together, you've got some really interesting dynamics. That's part that we have not done yet. We've just kind of just, we're not slow dancing yet.
Yeah.
You know, we're still sort of keeping away from each other. But whenever our students, when they're you know, in the plant, and when they talk to the young aeronautical engineers, there seems to be a spark.
Yeah.
There's a common thread that they're creating, that new patchwork.
Yeah.
And where that's going to go, I have no idea, but I love it.
Yes.
It's sort of building in the shadows.
I would say that would be true. When you think about architecture and aeronautical engineering, aero tends to be more physics-based. We have requirements.
Yeah.
A common question that I get from the students is, well, do you think if a tornado comes through that it could withstand it? And I go, well, do you realize that an airplane, it lands at 145 miles an hour. It cruises in the air at minus 60 degrees.
Yeah.
It flies 600 miles an hour. And then when on the ground a tornado comes through at 80 or 100 miles an hour, it's nothing. You can sit there and watch it come by and have a cup of coffee and watch it go right on by. It's just a total safe haven, you know, really where you're going. And if you think about the design aspects that we have to consider in the design of an airplane.
Yes.
Air flight right now is the safest it's ever been. And I always found this interesting. Think of a tornado.
Yeah.
There's so much energy wrapped in. Now, how can we use that tornado to really be it? What we do today is we run and hide in the basement. That's what we do, and you hunker down and wait for this thing to blow your house apart. Why is that? Why are we afraid of all that energy? Why don't we look at it as a playful thing, to play with the environment? The Dutch, for example, they're below sea level.
Yeah.
They look at water as something to play with. They're neighbors of it.
Yeah.
Water comes in. When's the last time you heard of a flood in the Netherlands? When's the last time you heard of a flood here in the United States? Last year? In the Holland? Never. I mean, it's been a long, long time. When you look at the environment and our ability, the Weather Channel, it predicts tornadoes. It can predict hurricanes coming in. We know it's coming. So how can we use that information
That is fascinating,
to
Roy.
provide safety? And why is it we're afraid of it? Why can't we play with it?
Yeah.
Why can't we be part of nature?
It's been a fantastic conversation, and I can see a lot of exciting things coming out of this. Continued conversation between Boeing and Ball State, and between aeronautics and architecture, and I can only imagine what exciting things the students are going to come up with in the coming semesters and years. And very much looking forward to following this along and facilitating and participating in this excitement. But thank you so much, Roy, for joining us on a short notice, and hopefully we'll continue the conversation for much more interesting and fascinating developments for both the industries.
Thank you for the opportunity.
Thank
Harry,
you.
thank you for
Thank you for
your
the
leadership
opportunity also.
on this, and look forward to wonderful things to come out of this. Appreciate it. Thank you.